Okay, well, I'm going to make a start. I think most people have arrived now, and hopefully any others will pick up very quickly from what we're doing today. Well, welcome to this sort of mini webinar, I suppose we'd call it. We've given the circumstances going on through the world at the moment, we decided about 2 weeks ago that rather than perhaps doing our normal series of webinars where we perhaps focus on a topic for a few weeks or whatever it might be, we're going to actually do a week by week series of mini webinars called Kwiklearn. And in the Kwiklearn series, we're going to cover a very different topic every week. So for example, this week we're looking at using MRDCL, our advanced tabulation software. Next week we're covering communities. And if you go to our website, to our events page, you'll see there's a whole program of things that are coming up. And the idea of these is to perhaps not cover topics in full, but perhaps cover smaller topics and give you ideas, perhaps show you how to do some clever things. And today's one very much fits into that category of how to do some things in MRDCL so that you can be a little bit more productive and hopefully get a bit more out of the software that you use. So this is to some extent mainly aimed at perhaps people who already use MRDCL this particular week, although anybody who's thinking of using MRDCL, and I think 1 or 2 people are on this session who are in that category, will get an idea of some of the quick things you can do and some of the ways to use MRDCL. As usual, if you have any questions, I'll probably take them all at the very end. But there's a Q&A box that you'll see where you can type in the questions, and if any questions come up, we will try and answer those at the end. And the idea of these Kwiklearn series really is sort of quite fairly quick fire stuff. So what I'm going to be covering today using MRDCL is to show you 5 ways that you can actually use MRDCL very efficiently, just spending 2, 3, 4 minutes on each topic before I move on to the next one. So a very quick webinar of this with some quick ideas. So I'm going to get on with it now. I've done enough talking about what I'm going to do, and I'm going to go and start to work on some projects that I've got ready. So if you just give me a minute, I just closed this, I think, accidentally, but I have to reopen it now. So we've got 5 examples. In fact, I'll already tell you might have seen me there. I've got a bonus example at the end. So you're really lucky people. You're going to get 6 things to see this morning, even though it's advertised as 5. So 20% more with MRDC than perhaps you might have expected. So where I'm starting today is, and the first topic I'm going to look at is thinking about multis. Now, one of the things that comes up in support from time to time is that people come to us and say, my run doesn't work, or my run is unusually slow. What can I do about it? And the first thing that I usually look for is to see how they've used multi-response variables, because it's a fact that in MRDCL, the one thing, if I pick one thing that uses up the most processing power and will slow down your runs, will be multis, and multis that are big. If you think about what MRDCL is doing with a single variable, it's just holding one value, and what it can do behind the scenes is just treat that as a number. So even if you've got 500 brands in a single variable, if it's the 431st one that a respondent has chosen, it can just store that effectively as a number. So it's very easy for MRDCL to store that. If it's a multi and you've got 5,000 brands, for example, MRDCL has no way of knowing whether you've chosen, or a respondent has chosen, all 5,000, just a few of those, one of them, none of them even. And so it has to recall for each of those 5,000 responses whether it's got it or not got it. And so it's like having 5,000 singles in terms of processing behind the scenes, albeit the 5,000 singles of yes, no, if you like, or 2 responses. So they tend to be very slow to process, or slower to process. So whilst in a normal project, multis are fine and you can handle plenty of multis and you won't notice any degradation in runtimes in a normal project, if you abuse this or misuse this, you can start to get slow runtimes. And the first one we got on the screen here is a very good example. I get this in support probably about, I don't know, 3 or 4 times a year, where somebody at the top of their script decides they want perhaps 200 variables called ZZ1 to ZZ200 that they're going to use for some unknown purpose. It might be to bring some back-coded data in. It might be some any purpose that I can't imagine myself. But what they do is they don't just set these dummy variables up so that they can use them. They just say, well, I don't know how big I want them, so why not make them the maximum I can, 9,999 responses? And guess what? MRDCL, with great loyalty, goes and does that, but the result is it's building very big variables. Now, on a project of 500 respondents, you wouldn't probably notice any degradation in the terms of the run times there. It might take, I don't know, 5 or 10 seconds, or rather than 3 or 4 seconds to run a run, and this won't be noticeable to you. But if you start putting through 500,000 records, or you've got maybe 1,000 or 2,000, 5,000 tables, suddenly that starts to impact on the processing time. And my advice would be, don't just dummy define big multivariables because you might need them. If you need them, that's fine, but set them to the length you want. So it would make a huge difference if we just set that to 999, because that's approximately 1/10 of the size of what I had just now. And if 1,000 responses is enough, and more than enough to work on whatever I want to do with these dummy variables, you'll get a lot more efficiency. And if you can make it 99, you've made it 1/10, even less, by making 1/10 of that size. So give that some thought. Don't use dummy variables just because you can. Use them and think about their length when you set them. We've got another example here where this is perhaps more to do with untidiness and having to do more work later. But I quite often see this where perhaps you've got 20 variables for brands A through to brand T, I've said here, and you want a variable for each of the rating scales here. So as is quite normal, you might define Q1 underscore A X as being whatever column it is, codes 1 to 5, to pick up a rating scale of very good to very poor. And then you might say, well, I want a top 2 box. So what I'll do here is I'll read from that variable and have a top 2 box that picks up the first 2 codes and the 4th and 5th codes for my top and bottom 2 box. Now that's all, that will work, no problem with that. But if you think about it, you're wasting a variable here. You don't really need that variable. And actually, if you come to export this to another piece of software, you'll actually have 2 variables there, which almost certainly anybody you're transferring this data to won't want or will be confused by. So it's not a good idea to have these 2 variables. It's better to have one. So rather than doing this, you could just go straight to a multi that picks it up. There's no need to have an intermediate variable there that picks up the first 5 codes. I know sometimes that when you import to MRDCL or you export from one of your own systems or whatever it might be, you sometimes get all those single variables. If that's the case, it would be good practice to make that a dummy variable. So by putting an X on the front of that variable, it's still picking up the first 5 codes, and then you're converting it into your top 2 box, bottom 2 box, and the 5 codes you want. But this is just a dummy variable. Now, by putting X on the front, that means that it's temporary. It doesn't get written to the IDF. You'll keep your IDF smaller, your runs will be faster, and you'll get the benefit as though it's just something that's used in processing, and it won't waste, or it'll waste such a negligible amount of time that nobody would actually notice that. So I do encourage people to make variables that you don't want temporary by putting an X on the front, and your runs will be more efficient. And also when you come to do exports, this wouldn't appear on an export. This would disappear because it's not written to the IDF. And again, you wouldn't have that work you have to do later of saying, I don't want this variable because it's almost a duplicate of another one. So just to see that running, just in case anybody wants to look at that in listing format, let's just go and run that. And as you can see, I've got pages of tables here coming out with the top 2 boxes. And if we look at the listing file, that's what I left in there. That's what I really don't recommend. As I say, you didn't notice that probably taking any extra time on a project with only just 1,000 records, but if it was a big project this with lots of variables and lots of tables, you would see some degradation. So that's what I say, don't do this. And if we scroll down a bit further, you'll see that my other variables here now, I've got that as a temporary variable, Q3_1, and then I pick up from XQ3, and on my IDF, I no longer have this temporary variable here. So that's a good thing to do when you're using MRDCL, to try and think about what you're doing with multis, because it's one of the things that can make a difference to run times on big projects. As I say, on a small project, that really won't matter too much. All right, so let's, I think I've managed to close a window again. I've done that twice now. Let's go back. So let's go to our second example, and the second example is assigning values to typically serial numbers, but not always. So what I'm thinking of is I see scripts that look like this, where people have either written the code out longhand or used the preprocessor to say, if serial number is 1, I want score 1 to be 9, down to score 20. If it's number 2, I want all these values to be assigned to score 1, score 2, down to score 20. And this just goes on as lines and lines of tables till we get to the 1,000th respondent number, where we assign these particular values for their scores. So this is quite a common thing that you want to do when you're perhaps using backcoding open-ended data, or pulling in some extraneous data that you've got about respondents in your survey where you want to merge it in. Now that all works, nothing wrong with that. It will do what you want, but if statements are probably the second biggest thing that will make your runs bulky and slow to process. Again, if we run this little project here, it won't notice, but on a big project, it will make a difference. So there's a different way of approaching this. And if we open up a CSV file, so those figures you saw there have all been extrapolated from a spreadsheet like this. So these could be clusters, they could be values you've got somewhere else, they could be any sort of data that you have that's extraneous to your survey data. So here we've got the respondent numbers, which go down to respondent 1,000. And these are the values I want to assign for each brand, going across to brand number 20, I think there on the right-hand side. So effectively here, we've got 20 brands by 1,000 rows. That's 20,000 rows of figures we want to feed into MRDCL. If we do it through if statements, that's 20,000 if statements. And of course, it could be more brands, it could be 10,000 respondents. And again, we get this problem of everything being 10 times bigger than it might have been. So let's look at a better way of doing this. And this is the script that I've got, which I'm going to show you in the listing file because it's a lot easier to read. But if we go to the listing file here, you'll see that you can have a construction that's like this, which does exactly the same. These 20 lines here do exactly the same as the 20,000 lines above it. So this is clearly a much tidier way of doing things. And in terms of efficiency of MRDCL runs, it's fantastically faster. So all that I've done here is I've defined a variable called records, which is IOBS 1 to 1,000. So they're my 1,000 serial numbers. And then I've assigned a variable called points 1 to 20, which pick up the records and they input these values 1 for 1. So that's the value for respondent 1, that's the value for respondent 2, 3, 4, and 5, and 6. And if we go back to my spreadsheet, you'll be able to read that off as 9, 7, 7, 10, 7, 1. There they are, 9, 7, 7, 10, 7, 1, and so on for the 20 sets of figures. Now that's really efficient code. That takes seconds because again, if you think what MRDCL is doing, it's not processing if statements and checking 20,000 lines to see whether a respondent fulfills that criteria. It's just assigning things one for one, effectively inputting numbers, which if you work with Excel and a spreadsheet, you know how fast you can just update a spreadsheet and everything updates pretty quickly. So it's really fast to run. In the example file, you can see I've written that in just 4 lines of code. That's all it's taken. Define the variable, run a loop that reads that input, that CSV file, and it's generated everything for me. I won't go through that syntax just this minute because that's not the purpose of this particular webinar, but all these files I'm showing you today will be sent out after the session, and you'll be able to look at that. If you've got any questions or don't quite understand how that's working, just drop us an email to our support and we will talk you through it or explain it in a bit more detail. So there's a second example of how to use MRDCL more efficiently. On we go to the third example. And the third example, I'm going to look at the data this time. Now, this is something that we encounter quite a lot in market research, where let's say this data, here's the respondent number, maybe the gender, then the age, and then you get these blocks of data that are repeated. So if you think of this data as this field here, the first 2 digits being the brand perhaps they're talking about, and then 5 statements about that brand, then the next brand they're talking about and 5 statements, and so on. So this respondent's talking about brand 1, 3, 7, and 2, whereas this respondent's only talking about brands 3, 5, and 1, and the fourth respondent's only talking about brand 6 and giving 5 ratings with it. Now, it's very tempting to just write this as a loop. Again, people can write loops that generate a vast amounts of code, and whilst that's a good thing because it reduces the amount of work you have to do, I'm pleased to say, sometimes it's easy to write a loop and not really think about what it's doing and what it leaves you with afterwards. So something that you might do with this, and I've opened the wrong file here, so just give me a minute while I go back and open this file here. So what I've seen people do is they write a variable that goes product 1 rating run is these codes, product 1 rating 2, product 1 rating 3, right down till they get to product 7, is it product 4, rating 5. And so rather than they've multiplied out the number of variables that they need, and of course that's very quick to do in the preprocessor. All you've got to do is write a little loop that picks up the 4 brands and the 5 products, and yep, you've got 20 variables coming out just like that. Now, that's not the way to do it. The better way to process this is to tell MRDCL these are repeat blocks of data. So this is not these blocks here are exactly the same, except they're talking about different products. Because if you do that, you'll then have data brand based in this particular case, which will make it much more efficient to process in terms of runtime, but more importantly, much more efficient in terms of doing tables. So if we did it the first way that I described, where we pick up each of these things as a separate variable, so we get 20 variables across here and 1 for the product, or 4 for each product, that would become quite unwieldy to deal with. So if I wanted a table on product 1, I'd have to filter on this field here being 01 and add it to this field if it was 01, and this field if it was 01, and this field if it was 01. So I'd have to add the tables and have 4 tables for every table to see whether each block represented data about product 1, and then the same for product 2, then product 3, and so on down to product whatever number it is, 10. So I'd start to get 4 times the amount of tables, and of course if there were up to 10 of these blocks across here, I would need 10 times the number of tables. So the whole thing gets more unwieldy, and to find combinations such as people who used or bought brands 1 and 3, for example, would start to mean quite complex definitions. I would need to say, did they choose 1 or 3 here and 1 or 3 here and or 1 and 3 here and so on? And it all gets quite complicated, the logic. Whereas if you process it using this as a block that's repeated, it becomes very efficient. Now, there is a video that covers this in great detail, but the basic principle is that you set each block. So what this loop is saying here is put each block of 10 columns back into the first first 11 to 17, the first 7 columns. And if there's a product there, go out and process the product, so that we're dealing with this as a product-based piece of data. And then we can just read the product as it goes out to this bit of code. And what's actually going to happen is a respondent will loop through this section here, the product section, as many times as they have products. So if we go back to our data, respondent 1 would go through that code once, twice, 3 times, 4 times. Respondent 2 would go through 3 times, down to the 4th respondent going through just once. Then the tables become very easy, because you can filter on whether you're doing respondent-based tables by assigning a level variable, or whether you're doing brand-based or product-based tables. And there's a whole video on this that does this, goes through this in a little bit more detail than I've got time for now. But if you've got repeated blocks of tables, the message is look at doing it by this go out to method and treating it as blocks of repetitive data. And you'll not just get more efficient run times in this case, you'll actually reduce your preparation time, your spec writing time significantly. And the more complex the tables are, the more you reduce it by as well. So it really is something that's worth learning if you encounter that sort of data. All right, that's 3 things. On to the 4th topic that I've got lined up for you today in this little mini series. This is a really quick one, and it's funny how sometimes you show people things that have been in the software for over 20 years. I showed this to a user who's used our software for over 20 years. I hope they're not embarrassed if they're on this call. And they didn't know this facility existed. And it's a very simple one, but it's a very efficient one. Sometimes you write loops that maybe, this is probably slightly exaggerated, but 1,000 rating statements, where you want very good to very poor for each of those 1,000 rating statements. And it's very easy just to put that in a loop. And sure enough, you get Q1 to Q1000, and you get these labels assigned every time. A lot of people don't know it's actually a lot more efficient if you set a global X dollar. So if you do this, if you set global X dollar, it will assign those texts to every variable, assuming it fits the right size. So this has got 6 labels here, very good to very poor and not stated. This variable happens to be 6. So what MRDCL says, well, if this is 6 in length and I've got a global X dollar running, I'll just assign that to every variable in here. And you will see some differences in your run times. If you want to stop it doing that, it's very easy to unset it. You can just literally say global X dollar unset, and everything after that wouldn't apply those global X labels. But it's just a really quick tip that can save you some runtime on a big project. So that was a real quick number 4 there I slotted in. Let's go on to number 5. I've gone back too far. Now, this is something that I often see this with quantum users who or people who are converted from quantum to MRDCL. We've got a huge number of people who used to use quantum but have moved on to our software to use the more modern facilities with MRDCL. And the sort of thing that I've seen is something like this, where they want to assign a value to something. So I saw this most recently where somebody wanted rolling periods. So they thought it would be a good idea to write a loop that said, if week is 1 to 4, rolling period 1 is a 1. So they can set a set of values of 1s and 0s effectively. If it's 2 to 5, rolling period 2 is 1. If it's 3 to 6, down to if it's 20 to 23 rolling period, 20 is a 1. Now, I can see why people do that, and the reason that people do it when they come from quantum is quantum's very card column based and MRDCL is very variable based, and I think people feel a need to, as they can't, or they can't, you could recode this to columns on data as well if you want to do MRDCL, but they tend to use sort of assigned variables when they don't need to, and there's really no need to do this. This is pretty inefficient code. What you're going to end up with here is 20 variables sitting on the IDF that you wouldn't want to export, I suspect, ever, if anybody wanted an export of the data, which are just going to be carried around unnecessarily all around the project, whether you're going to do tables, export it, whatever you're going to do, you're going to inflate the size of your IDF with a whole load of pretty unnecessary variables. So this is just an example. I've seen plenty of other examples where people are setting variables to 1s and 0s when really there's no need to do it. So let's look at that script that generated that and look at a different way of doing it. So if we open this up, so that was the pre-processed version you saw there, but you can see what I'm doing. In a loop of 1 to 20, I'm saying if weeks 1 to 4, 2 to 5, 3 to 6, and so on, set the rolling period equal to 1, so that the banner can be picked up as being a series of 1s for each of the 20 rolling periods. You just don't need to do that. I mean, this is just so much better. One statement, and you can just pick up all that information there, with the week being the rolling periods 1 to 4. So if we look at the listing file of this, I just go down, there we are. That's the code that preprocessor generated, and that's just a lot more efficient. It's just going straight in from the variable week. We need to pick up the variable week. I think that's a perfectly sensible thing to assign, but then you can just assign it to the variable banner. And I think that's a general rule in MRDCL. Again, people converting from quantum do find this, that there's I tend to see in scripts an overusage of variables where they're not necessary. I tend to teach people and tell people to only pick up data once, and then once they got it in that variable, to not replicate this by making unnecessary variables if they can. So that's just another way of doing it, and it works perfectly well and is much more efficient. And I promised you a bonus example to give you 6 rather than 5, and I'll finish by looking at something else that I have seen people do, and it's this sort of code here. So for example, here it's not used, it's when people fail to use dot by dot and dot or dot constructions, and also dot and dot, there's also dot not dot, which would make specifications so much easier, much more efficient, and much less code to process. So the first example here is we've got the brand most often picked up here as brands 1 to 100. And then we've got a multi, which down here, which is brands also bought, which it is a multi. And what we want is to put the most often and all the also boughts together as brands, all total brands bought or all brands bought. Now we can do that by saying star do 1 to 100, pick up all the values of 1 to 100. So let's just look at that when it's been pre-processed. So let's scroll down past all the brands. So it generates some code that looks like this, where it says brand most often a 1 or brand also bought a 1, all the way down for the 100 brands. And of course, if that was 1,000 brands, or if it was adding together or oring together lots more variables, it would just get bigger and bigger. That's really an efficient use of MRDCL when you have a construction that looks like this. So you can say DM $brands bought is brands most often dot or dot brands also bought, and that's doing exactly the same as those 3 lines of code there, with one minor exception which I'll come to in a second. So it's doing exactly the same as that, but doing it in a much more tidy and efficient way. The only thing you need to do extra here is that because we've got a not stated on the end, it would altogether the not stated. So if anybody said not stated, so if they chose brand most often, but said none other or not stated for other brands, you would get people with the dot or dot coming into the last bit. So all you have to do is redefine that brands bought as brands bought being 1 to 100 and redefine the none or the no answer so that it does what you want. That's one example. The other example is something I know people want quite a lot, where you get things like this. So you have age here as a variable, region here as a variable, and you want age within region, or region within age. So you've got 20 regions and you've got 5 ages here, and you want to make a variable of 100 answers. Again, the preprocessor will do that for you very efficiently, and you could generate the labels for that. So I actually got some preprocessor code in the STP file here. If I go to the STP file, it would help. Oh, I was in the STP file. Sorry, I'm getting confused myself. So yeah, we've got that here in a nice loop. But again, that's pretty inefficient code. There really is no need to do that. You have a command, if I just scroll down this file, which does that, all of that script there that you can see in just one statement. So ds$banner is age dot by dot region will give you region within age. If you wanted age within region, you'd say region dot by dot age. You can have multiple variables there. You could, if you wanted to go gender within age within region, you could do gender dot by dot age dot by dot region, and it would expand it out into 2 genders times 5 ages times 20 regions. So you can do make really big variables out of that, and it works perfectly well with multis as well. So if you want to do a dot by dot with multis, so if you want brands bought within age, you can just do brands bought dot by dot age to make a new variable. So there's my 5 efficient ways of using MRDCL with that bonus one on the end there. If anyone's got any questions, I'll be pleased to answer them or try to answer them. But that's it for now. I'll just quickly check if there's any questions over here. I've got one question. Is there any limit to the number of things you can dot by dot? I don't know the answer to that. It's a good question. I think you can dot by dot as many things as you like, and when you do it, it mustn't generate more than 9,999 responses. So if you did age within gender within region with brand most often within something else, and that multiplied up to more than 9,999 responses, you wouldn't be able to do it. But otherwise it will work fine. In most cases you wouldn't want that many. So yeah, you can do multiple dot by dots to any depth that you want. All right, I don't see any more questions. So at that point, I'm going to close this session. Just a reminder about our quick series. We're doing one a week of these Kwiklearn series. Next week, they're on Wednesdays at this time for the next, I think, 8 weeks. Next week is about online communities and seeing the things that you can do within our online communities platform. You won't be seeing me on that one, I'm afraid, but Nikki will be leading that one next week. But thank you for joining. We will be sending out the video of this shortly, and also all the example files that I've been using today. If, having seen those example files, it makes you want to ask more questions, just drop our support a line and we'll try and answer those for you. Or if you think they could be helpful, but with a bit of adaptation could really do something really powerful for you with a bit more knowledge, just ask us and we'll try and point you in the right direction. But thank you for joining me today. Hope it's been useful to you, and I'll say goodbye to you and hope you all stay safe and stay well. Thank you.